We're just going to briefly go through some of the fun that we as in Christie, had with some of our NetApp implementations within our business roughly about a year ago. I guess before we get to there, I should introduce who you're actually going to listen to for the next 40 minutes or so with just 75, 76 slides. That'll be great. I'm Scott Elliott. I work at Christie. I've been there for about 5 years. I'm a senior sysadmin. Now, somehow they decided to make me manager, so I have a team of about 5 guys reporting to me, working on mainly the virtual infrastructure and a little bit of the storage.
And I'm Keith Asen. I'm a consulting systems engineer specializing in virtualization with NetApp. I worked with Scott numerous years in the past and assisted Scott when they started to have some system initially with the original architecture and then started to help them when they had initial performance problems in this environment.
So again, briefly, we're going to go through, we just introduced ourselves. We're going to talk about some of the backstop or the backdrop of our story. We're going to go around how storage problems kind of appear and how they can really put a damper on your virtualization efforts. We're going to go through some of the root cause analysis that we went through, some of the things that we found and how we fixed it, and we're going to talk about the results and hopefully what we want to do next. So first things first, I guess a word from our sponsor. Christie is a global visual technology company. We design projectors, digital projectors. If you were at the keynote this morning, all the big, huge blocks of projectors hanging up from the rafters, we actually made those. So some of our solutions include media walls. So you can see there on your right, there's the media center for the NASDAQ. That's using all of our technology there. Media walls can also include network operation centers, like the one on your left. That's actually our network operation center in our California office. We also do digital cinema projectors. So AMC, I believe, is a big theater chain that has a lot of our projectors for all their movie houses. We also were part of the premiere of the Pirates of the Caribbean. I'm not sure which one that was, but rest assured Johnny Depp was in there and he acted very drunk. We also, with our digital projectors, we can also do kind of neat stuff. The picture there on the right, that's an art exhibit projecting on the outside of buildings, playing different scenes in a continuous loop over like a 10-minute period. We also do some 3D virtual reality. So we create what are known as caves. We put a whole bunch of walls around you, project onto them, you slap on a pair of really funky 3D glasses and it all pops out. It's almost like the holodeck. It doesn't push back yet, but pretty darn close. We also create simulation projection systems. So for example, the one on the right, that is a simulation system for captains of large steamers trying to figure their way out through the Suez Canal or something like that. Apparently, the owners of the said boats don't like it when you brush up against the sides, so they probably want them to practice on it. The one on the left is actually a tractor trailer with 2 Apache Tomcat helicopter sims, and they would either fly in exercises in teams or against one another. Probably kicks ass of any Xbox out there. To quickly talk about where Christie came through the virtualization journey, when I signed up about 5, almost 6 years ago, they decided, hey, there's this neat kind of thing out there called VMware, could you take a look into it? I said, yeah, sure. So we built one server, and it had one vCenter, or virtual center, I think it was called at the time, and we tried it out. And they thought that was pretty cool. You got one machine, you got a whole bunch of one physical box, and you got a whole bunch of virtual machines working on it. You know, we should try that someplace else. So we extended that into our California office. We tried it out there, and we built some more stuff back in our Kitchener office, and they still really, really liked it. They said, could you do a little bit more? I was like, giddy up. So we built some more. That got filled. We built some more again, and that got filled. Within a year, we had grown from one single host to 6 hosts in one location, 5 hosts in our California office. At that time, we really thought that, hey, we should really embrace this stuff and commit to it full hog. And then our Cypress, California office, we actually invested and had a virtual center, or vCenter, installed there. So now we have 2 distinct virtual centers, one in our California location and one in our Kitchener location. We've continued to grow. So again, I mentioned that we have one in Kitchener and one in California. We also have put one out in China, as well in the UK. Now, in terms of sheer size, the Kitchener office is still the largest. The California office comes in at a close second. They get the silver. Shenzhen, distant third. They're a much smaller implementation. And thanks for coming out to the game. We got UK with their own little 2-system deploy there. The large part of this presentation focuses on the fun that we had in our Kitchener center. So just to give you an idea of what we have at our Kitchener location, we have, at the time this presentation was created, we had 14 hosts, and they're kind of broken out into 2 pools. Some of our older hardware, they tend to be 2U boxes running IBM 3650s. They're dual proc, quad core, and they have about 50 gigs of RAM. Some of the newer boxes that we have, they're the bigger 4U boxes, the IBM 3850s. They're quad proc. These ones have 8 core, and they have about 256 gigs of RAM. So those are the 2 main platforms, and depending on the workload and depending on how crucial it is, gets flipped onto one of those 2 types of platforms. Our storage all across our virtual centers, we are using NetApp. In Kitchener, we're using a slightly older model, the 3140. It's coming up onto 3 years, so Keith is really excited because it's time to renew. And we're using about 60 terabytes of space. And again, we have about 250 VMs booting around in our Kitchener side. That's always growing because, like rabbits, these little guys tend to reproduce themselves quite quickly. Just a bit of a level set in terms of the problems that we've experienced. The problems that we actually, as in Christie, actually experienced had to do with disk latency. So just to give you an idea of what kind of a general, what's considered good, bad, or ugly in terms of disk latency, when measured, how quickly the storage subsystem responds to either a read or a write request. If you have anything less than 20 milliseconds, that's usually pretty good. And that's everything's shining, everything's working exactly the way as you planned. When you get between 20 and 40 milliseconds, you're going to start to creep into the warning range, right? Like, applications will still respond. You probably won't notice much, especially the business users won't notice a whole heck of a lot that's going on in terms of badness. Everything still seems to be going, but that's when you're going to start to be somewhat concerned. Anything in excess of 40 milliseconds, that's when you really start to experience applications having problems. That's when you start to experience business processes collapsing in the middle or somewhere through transit. So if we have that as a backdrop, when we first implemented the NetApp, we would, of course, jump onto the console every once in a while and just take a look at how are things doing. Our sustained latency was really well. It was well below the 20 millisecond threshold. The spikes that we happened to notice, again, quite low below the 20 millisecond threshold. We were ecstatic. Hey, we just paid a whole bunch of money for this really cool storage subsystem. We went to town and we started deploying like mad. The latency numbers that we got there, unfortunately, we were only kind of noticing them by we just hop on the console and take a quick look. Yeah, the number looks great. Let's move on, just deploy some more VMs. NetApp also provides a Microsoft System Center Operations Manager plugin, so you can constantly poll your NetApp to see what your disk latency, amongst other counters, to see how it's doing. Well, we thought we just paid a pretty penny for this storage subsystem. We're putting a lot of really important VMs on it. We should kind of pay attention to it, probably want to keep the job for more than 6 months. So we deployed the SCOM plugin. Again, applications were going just fine, but we noticed something not so good. Our sustained latency in a lot of our data stores were well in excess of 20 milliseconds, and unfortunately, our spikes, they were well above the 40 millisecond range. What was weird is that the applications, though, they just continued to function along just fine. And it's really hard to tell a business, whoa, you can't have any more business compute power, you can't have any more virtual machines, we got to take a look at something. Well, what do you mean you got to take a look at something? Our storage subsystem is complaining. But is my applications impacted? Well, no, they're fine. What happens if I get one more application? Well, it should be fine. Well, then you work on it in your own time. I need more VMs, please. Okay, fine. Especially the guys that signed the check. You go out and you put more stuff out there. Continued growth. Christie has enjoyed a massive explosion of growth over the past couple of years, requiring a massive amount of virtualization compute power. One of the things that we implemented during this time period is we implemented a rather large SQL data mart, a lot of high I/O, a lot of calculations, moving massive amounts of information back and forth. And with that in mind, with the sustained latency previous, when we're like, geez, I don't know if we should put any more. Well, you shouldn't put any more, right? It went up in flames, not literally. Although I have heard servers going and bursting in flames. But we were having disk latency in excess of 1,000 milliseconds. Again, above 40 is kind of shitty. 1,000, that's not so good, right? So, and applications did kind of complain. Our Exchange implementation, as an example, it couldn't see its subsystem. It would fail over to its failover cluster in our California office. So business wasn't too thrilled about that. And as much as you want to go, aha, I told you so, they don't like hearing that either. So just to give you an idea of the magnitude of that, here is a quick chart of how some of these data stores were reacting. Again, take a look at that little circle there. That's 1,000 milliseconds. We're spiking well above 1 second of disk latency. Actually, the maximum that we had during this period was actually 6 seconds, where the OS could not see its disks, or it's waiting for that response. Again, not so shit hot. So just, again, a quick summary of some of the issues that we had here. Most of the data stores consistently existed above 40 milliseconds or higher, and our spikes lasting several seconds, like I showed you in that last picture, right? The ESX high hosts, they would complain, I don't have any storage right now, sorry, thanks for coming out. And it wouldn't be the same ESX host, it'd be random ESX hosts at different times of the day. We weren't sure what was actually going on there. And again, as I said, a lot of the applications, especially Exchange is really susceptible to high I/O latency times. A lot of these applications, they were starting to complain, and they were actually starting to fail over. So unfortunately, there's not a universal make it not suck bit that you can enable. You actually have to start combing through all this stuff, right? And where do you start? You literally have an ocean of data, an ocean of log files that you got to comb through. And the really fun part of it is it's not in one location. You have, at bare minimum, 3 different locations. You have to check out your NetApp log files. You have to check out your vSphere log files. And you actually have to go down to the VM itself. And once you get all that information, you have to figure out how to stitch all that stuff together. A leads to B leads to C. And to be able to stitch all that stuff together, you're going to need a little bit more specialized knowledge of, in this particular case, of how the NetApp really needs to function. Fortunately, by sheer coincidence, we were actually doing a proof of concept with NetApp on their on-command balance product. It is their kind of top-to-bottom analytical tool to kind of watch how things are going on, right? It does not only performance capacity analysis, but it does that stitching for you. Hey, you're having something happen over here. You probably should check this over here. It's more than just a, hey, you're having problems. It gives more information that way. We were using this. We supplemented the information that we gained from the on-command balance to what we were already gathering within our System Center, Microsoft System Center, and added with the NetApp perf stats. We started to compile stuff, and we noticed some really strange things. One, we noticed that there was a large amount of misaligned VMs. And Keith, because it's way too technical for me, he's going to go through and describe why that's considered bad. We also noticed that a lot of our latencies, tend to happen at really odd hours. It was between like midnight and 5 a.m. and we couldn't figure out why that was happening because everybody's asleep. What kind of big, huge push are we putting on the system between those hours? Somebody said, aha, it's the backups, but no, it wasn't. We actually shut the backups off and the disks still complain just as much.
So one of the things that we discovered from balance right out of the gate was yes, the system was heavily utilized, and the spikes were because both the system and the underlying disk was maxed out. We could have said that's end of job, right? Go buy more, move some VMs over, and keep going.
Which we did.
But we wanted to get a more underlying issue of why are they actually loaded, because as Scott said, the actual utilization pattern was very irregular. It wasn't like it was just had built up gradually to the point where it was overutilized. It was suddenly spiking to wild utilization numbers and right back down, but we couldn't correlate what was generating the I/O spikes. One of the things that Balance did an output of, and I'll show you a sample of the output a little later on, is the misaligned VM. Now, curious, here's your chance to stretch in the audience. How many people have heard of misaligned VMs? That's fantastic. How many people really understand why misaligned VMs stress disk systems? All right. Well, I got to entertain some other way. No, this is good. So this hopefully will complement that or confirm your understanding of the issue. That's great to know, because it was definitely one of the most misunderstood issues I came across in the storage industry. And I quite often get to know we're properly aligned. I created my VMFS file system with the GUI, right? I'm properly aligned. So as an example, here's a diagram showing a VMDK, a properly aligned VMDK, or a misaligned, actually, VMDK, sitting on a VMFS file system, sitting on underlying, in this case, waffle blocks. But this holds true for every storage vendor. Every storage vendor uses some sort of block schema, an inode table for their underlying storage, and it varies based on the block size. So you need to know, based on your storage platform, what block schema your storage vendor is actually using. So what we've seen here in a misaligned VM, even though the VMFS is properly aligned, you see the first VMFS block there lines up to the underlying storage block. That indicates that the VMFS is properly aligned. But if you look at the individual VMs, the individual NTFS blocks in this case don't line up to those underlying storage blocks. That's what we deem by a misaligned VM. So just having the LUNs themselves aligned is not enough. So why does that matter? Well, first, let's look at how I/O to the storage system should work. In this case, is a NetApp storage system. Notice in here, my master boot record or my starting offset is equal enough that all my VMs, all my blocks line up. So I've color-coded them. It makes it a little bit easier. You see the red block lines up, that's in the guest OS lines up to the underlying block on the storage. So if we add the storage array in here, we see everything, track it all the way down to the underlying storage. So in a properly aligned VM, when it goes to do a write, and this in particular for most environments, in particular for the case for Christie, it was the write load that was stressing the system out. So when we normally do a guest write, so the VM itself, the guest changes that underlying block, does a change to the data, it writes that down to the storage controller. Now every storage controller has write cache, and how they handle that write cache is differently. On a NetApp system, we will cache that right into NVRAM, and we acknowledge that back to the VM. So as far as VMware and the VM is concerned, that write has been handled. Now under the covers, we now take care of how do I get this write actually down to the disk. And with the NetApp, we're able to write that down into a stripe and just simply invalidate the old block. So it's one I/O in the VM, one I/O in the storage system, and it's very efficient. In fact, quite often because we coalesce writes, one I/O in the VM is not a one-to-one ratio. Quite often we'll coalesce the I/O coming through the VMs into much less I/O that actually hits the back underlying disk. So that's how it should work.
We didn't work that way.
Yeah, it didn't quite work that way. Here's a misaligned environment. So you see in here the individual blocks in the guest VM span the underlying blocks on the storage system. So my red block is actually sitting on two halves of a storage block, right? It lays out, it's slightly shifted over a bit. So follow the same write, right? The guest does one I/O write. It comes down here. Now here's a key thing to highlight, is most storage systems will likely still cache that and acknowledge that back. So what's the perceived performance impact to the guest? It's none, right? It's just as fast as it was. So one myth I get quite often is this whole misalignment thing. They go, well, you know what, you said I misaligned. I did a benchmark on the VM, and then I aligned it, and you know what, it wasn't any faster, so we're not going to bother. All right, so kind of a bit of a misunderstanding there is normally the system can cache those writes and it makes no change to the underlying performance of the VM. But look what we have to do to get these writes out of cache. So effectively what I have in my cache now is 2 half blocks. So can I simply invalidate my old half blocks or my old full blocks? Well, I can't because I still need those other half of the data. That other half block is still valid. So what we have to do to actually clear this write cache is I have to do reads of the disk to get those other half of those blocks up into memory. Then in memory, I can assemble full blocks, so those halves that I brought up, and then I can drop that down to disk. Seems like a lot of work, doesn't it? What has my one I/O, my one write in the VM become to the back-end storage system? How many I/O? It's actually 4, because I have to do 2 reads and then 2 writes. So I have a 4x multiplier in my underlying I/O going to the actual disk. But what was my perceived performance impact to the VMs? Well, it was nothing. The VM seemed just as fast. So effectively what you have with this misalignment is as long as the storage system can keep up, there's no performance impact. But it's the duck on the water, right? It looks really calm on the surface, but under the surface he's paddling his legs like crazy. That's exactly what happens with misaligned VMs is as long as the storage controller can keep up, there's no performance impact, but you're working that controller much, much harder. So the net effect is we have a much higher burn of CPU on the controller, much higher load on the disk on it. And what happens is as soon as the system can no longer keep up, bad things happen. As soon as I can no longer cache those writes, now I can only write to that system as fast as I can read from it. So we start reading from it as fast as we can write to it, the whole thing starts to bind down. What happens with underlying spinning disk? The more I/O you throw at it, what happens? The longer it takes to get the I/O, right? The I/O increases, so does the latency. And so you get yourself in this binding loop of you actually need everything to go faster, but everything's taking longer. So while you're taking longer, more I/O is piling up behind the scenes. And you get that wild latency spike that comes out at you at a weird time. So misaligning or correcting the VMs is a key part of it. So how to correct it? Well, we've had a tool in the market for ages, and there's several on the market now, including VMware Converter, which actually is one of our recommended ways of doing it, is to shut down the VM and actually fix that master boot record. A couple of things. One thing, as you likely know, all of the major OS distributors have fixed this. Windows 2008 and higher, all the current Linux distros have fixed that first block so it lines up properly. This is why you want to know what your underlying block scheme is on your storage, because it may vary from vendor to vendor. For NetApp, as long as it's 4K divisible, we're happy, right? So if that's 4K or it's 1 meg, don't really care as long as it's 4K divisible. So you need to shut down the VM and you need to do the conversion of the alignment. Well, Christie was not unlike many customers when we told them to do this. Before we fixed their problem, they're like, can't do it, right? We've moved our mission critical VMs in there. I can't shut these down. I can pick away at them over the next year through change windows and such, but there's no way, like we have this problem right now, you need to fix this problem right now. We can't shut down all these VMs and fix the problem.
To give you an idea how many, we were talking 72 to 80 of individual VMs that we would have to shut down, and business owners like finance or engineering, they don't like to be told, by the way, you can't use your application right now.
So a bit of a challenge. Here's an output of the balance report that we got as far as detecting the VMs. So it shows the VMs that are misaligned, and I'll just kind of highlight, because there's a bit of an eye chart there. But it shows that we rank them by average throughput. So we can see which of the VMs are generating the most misalignment. So we can see which of the ones you should target the first to actually correct. We also say how much are they misaligned by. So this one indicates here that it's actually 7/8 of a block off, or the starting offset is 3.5K when it should be 4K. So we can indicate by how much are they actually misaligned. And then we also say what's the storage configured offset. So what does that mean? Well, what we have the ability to do with Christie, and we started off with them very early in the process, but it's now available in the virtual storage console. So you can see a demo of this down at the NetApp booth. But we had the ability to scan the virtual machines to detect how much are they misaligned by, and through our plugin for vCenter, we can build a LUN on the storage controller that it itself is misaligned, but misaligned by the correct amount. And then we can just do a storage vMotion by the VM into that misaligned LUN. right? Clear as mud, right? And zoom in a bit. Here's what it looks like. It'll show you the VMs that up top there are functionally aligned. These are the ones that are properly aligned by whatever the underlying storage subsystem is, in this case 4K blocks. The next ones down are showing, the actually aligned or the correctly aligned. The functionally aligned are the ones that we actually fixed by creating these offset LUNs. So what we actually do is, you see here, we actually shift the VMFS file system over just enough so it doesn't line up quite right on our storage subsystem. But what that allows us to do is, if you take a look at the actual blocks inside the VM, now they line up properly to the storage system. So without shutting the VM off and leveraging VMware Storage vMotion, we can move the VM into one of these optimized LUNs, and we can eliminate the misaligned problem. So as you imagine, this drastically reduced the amount of I/O and CPU load that was on the storage controller. And what that did was clear away a lot of the data that was making it hard to determine the root cause of the problem. So now we drastically reduced the number of spikes, but there were still spikes that were occurring. But because there was fewer and they're not scattered throughout the entire day, the remaining ones were at consistent points of time. And so what we had to do is kind of say, well, what happens at those particular points from a storage subsystem? Now, every storage system may have different background processes that occur. In our case, we were seeing one of the big latency spikes was occurring at the same time as we did an aggregate level snapshot. Now, aggregate level snapshots on the NetApp happen to be a background process that's turned on by default to really protect the administrator from something bad, like deleting the wrong volume or having an aggregate fill up, letting you roll back before that actually occurred. But it was a coincidence that these latencies were happening at the same time. But not on every aggregate snapshot, but only on certain ones. What we actually, by doing a little more digging, is discovered that we were actually releasing a large number of blocks during that snapshot cleanup process at the same time that Christie was doing one of their big processes on SQL. So the load generated by their SQL database was conflicting with our snapshot process. It's pretty easy. Let's test it. We turned off the snapshot. That latency spike went away. So it was good for us to actually discover that. We actually, since in the ONTAP version, have been able to lower the priority of that particular process to prevent collisions like that. But it was really key for us to determine what's happening on the storage array as a background process and versus what's happening for you operationally in the VMware environment.
Needless to say, Christie was absolutely pleased to hear that our own blood, sweat, and tears was a cause for improving ONTAP, right? So we've eliminated the misaligned VMs, or at least we've mitigated it. We've taken a look at this background process, this background snaps, and we also did a little bit more granular snapshot management where we didn't snap everything all at the same time. We started to scatter them around throughout the day as well. But we still had weird VMs, weird data stores saying, yeah, I'm not here right now, thanks for coming out. So we reached into our toolkit and used one last tool. We used Veeam's management pack for VMware. It's a plugin that connects into Microsoft System Operation Manager. It's a way to monitor your entire virtual infrastructure agentless so that you don't have to install a full-blown operations manager install or a client on each one of your individual VMs. You can just kind of monitor it at the API level very, very high up. It doesn't give you quite the breadth of information that a full SCOM client would have, but it does give you a lot of information and a lot of information stretched across your entire VM infrastructure. So that was really cool for us. I'm sure they don't know that I'm talking about it. So afterwards, if you can just go down to Veeam and say, hey, Scott sent me, tell me all about management pack for VMware, I might win their lab. That would be awesome. Be great if you guys can do that for me. You guys don't need the lab, right? So anyway, one of the reports that we had in here was virtual machine disk performance history. We thought, well, we're having problems with our disk performance. How about we take a look, see what's actually going on? So we pulled up some of the information. This is one particular VM. And we noticed these kind of weird spikes happening here and here, which in and of itself, yeah, it's kind of cool, kind of interesting, but we didn't really notice anything in the event logs what the hell would cause this until we started looking at multiple VMs and laying them over top one another. As you play through these multiple VMs, we noticed that although the amplitude changed, the spikes seemed to happen always at the same time. That gave us more than enough information to finally stitch that last little piece together. Now that we know that, hey, something's really interesting happening at 3 p.m. and 6 a.m., let's go through the event logs on the VM itself and take a look through what's going on. And it turned out to be what we thought was a relatively benign process. It was the AV. Like we installed the antivirus in a very traditional manner. Okay, we have a VM, here's your AV client, go forth and be happy and be safe, right? What it actually was turning out was the maintenance of all these AV clients. They were synchronized to do the same thing at the same time across our entire infrastructure, right? In this particular case, it would go out and say, hey, are there any updates for me? I got to write them to my disk, or I got to do a self-system scan, right? One VM doing that at one particular time, no big problem. 300 VMs doing that all at the same time, hitting that storage subsystem at the same time, that's a little much for it. So the way that we mitigated that, we didn't rush out and buy a new version of AV. We just kind of did the Scotch tape and binder twine solution. We went in there and we basically said, okay, all you AV clients, start your processes, all your maintenance tasks right at midnight, randomized plus or minus 12 hours. So that was enough of a maintenance workaround so that we didn't have all the AVs kind of hitting our storage subsystem quite so hard. So with all that work, we're finally done, right? If you take a look here, and this is in milliseconds, not seconds, right? So don't go running off, you guys suck. But we actually are getting our storage subsystem back to where it's supposed to go. This is an overall controller viewpoint stretched across. We're actually existing well below the 20 millisecond threshold on a consistent basis. Now, we still do get the occasional spikes, but we know why we're getting the occasional spikes. We're either moving a massive amount of VMs using storage vMotion, and that's a lot of writes and a lot of reads, or we're moving a lot of data in and out, but at least we know why it's happening, and it's not just kind of exploding on us. So through this entire process, what did we as Christie learn? One, that if you're not pushing your subsystem hard, it can be extremely forgiving and can mask a lot of misconfigurations. Right? It's not until you start putting more and more workloads onto your storage subsystem that those little misconfigurations, which were quite small in the beginning, they become extremely impactful, and it can bring a lot of your stuff down to its knees. The other thing that we learned is that there's no single bullet. There wasn't that magic make it not suck bit that we can suddenly enable, right? We actually had to, in our particular case, we had 3 different things that we actually had to find to fix. And it wasn't until we fixed one of them that it kind of cleared up the waters a bit that we can discover the second thing and work on that, and then eventually work on the third thing. There wasn't something that we can do at the beginning to suddenly make it work. In our case, as we said, the 3 things that were giving us grief was our VMware, our VM misalignment. We had some storage contention with some of the in-house background processes of the NetApp, which, yay, it's no longer there for the next release. Thanks to Christie. And 2, we really weren't thinking in a virtual environment for how to handle our AV infrastructure. To be quite honest, we shouldn't have done that in the first place. We're currently going through the process of changing out, so we're not installing the AV at the individual client anymore. We're going to try to look at it smartly at the vSphere infrastructure, much like the SCOM monitoring. We're looking at the infrastructure, not at the individual VMs. There's also some other lessons. This is the bonus round for you guys. We also learned some other lessons. By God, and watch what the stuff is doing, right? Invest in some monitoring tools. Everybody says, yes, we should do monitoring. Not everybody wants to do it because it's a pain in the butt to actually set up and implement, and you have to constantly tweak to watch what's going on. But it pays off in spades when you come against this problem. Not only will it tell you that there's a problem happening, but you have the performance logs to go through and try to figure out why it happened in the first place so that you can go through and fix it, right? If you do come across a misconfiguration, try to fix it. Don't just ignore it, right? A stitch in time saves 9. Engage in your vendor. Keith not only helped us a lot initially with the design, the initial troubleshooting, he actually connected us to a lot of different people within NetApp, and they engaged a whole bunch of other people, kind of like that old shampoo commercial. You tell your friends, and they'll tell a friend, and so on and so on and so on. We got the whole of NetApp empire trying to fix our problems, working with us and trying to fix this. And more importantly, if you engage your vendor early in the process, they usually take you out to lunch. So that's important, especially one as nutritionally endowed as I. I like my lunch, right? Famine resistant. So, with those slides, we got a ton of time. We got about 20, whatever until they kick us out. Any type of questions that you guys have about our system. I saw your hand first.
Yeah, so your antivirus situation.
So the question was doing the antivirus at an infrastructure level. There's a lot of different vendors out there. Trend is one, for an example, where you install the antivirus for your vSphere host, essentially. Instead of installing the antivirus on your individual VMs, you can install it, watch it at the upper level, and you would need something like your vShield or vEdge to kind of integrate all that together so that you just have one antivirus kind of watching all the activity of all the VMs, but it's happening at a host level, and you're having one process for the host as opposed to 20 processes for the individual VMs.
You can also run it right on the NetApp storage array. Integrated antivirus runs right on the array and watches everything. Very low level.
Are you from NetApp?
Used to be.
Okay. You can run it on NetApp as well. Is you had another question?
There's a question here. Yeah. Oh, sorry.
Yes. We weren't using cache, that's for sure. We didn't have at the time, a PAM card.
So the question was, what was the back-end disk type? Was it SAS, SATA, or were we using flash cache? So the background was using SAS disk, and it was using a Generation 1 PAM card, so a 16 gig acceleration, but it was still stressing the actual back-end spindles, so we did actually increase the spindle count as well, but correcting the misalignment drastically lowered the CPU, which is also where we were hitting the max CPU level. Sorry, there's a question here as well. The question was, what was the CPU reduction on the storage system? I can't actually say for the Christie particular environment what it was. I've seen other ones, though, in the 35 to 40% CPU reduction. More importantly, though, we weren't maxing the CPUs. They weren't maxing out when we hit that. Can no longer. I got so many partial writes that I can't deal with this anymore. So we had lowered the CPU, a significant amount, but more importantly, we weren't maxing it like we used to be. Sorry,
yeah.
Pick next. So the question again was, what was the back-end storage type we were using? Yeah. Yes. So the question was, we were using SAS disk on the back end, and yes, so in initial collection, both the disk and the CPUs were maxed at periods. So there's times that it was really low utilization, but during these high latency windows, yes, we had 100% maximum disk utilization and max CPU utilization. So at certain times, the system was just absolutely slammed. We've actually increased every version of ONTAP. We're getting more and more. The question was, what version of Sorry, I got to remember the question. The question was, what version of ONTAP is one that's dividing out all these background processes? Every version of ONTAP is getting more and more multiprocessor aware and more multi-threaded. At the time, Scott was running on 8.0.x release, and so the 8.1 again, it increases every version is more multi-thread aware. Next.
There's a guy in the back. Yeah.
We have several pairs of 3240s. We have SAS and SATA disks in the system, and one of our biggest issues is we're seeing a lot of high watermark CPs. In fact, all we get are high watermark CPs, and then sometimes back-to-back little Bs and sometimes big Bs. So one of the things that support is now coming at us with is that just the presence of SATA disks in the system causes significant performance issues with how the NetApp writes down the disk. Can you elaborate on it a little bit? Is that true?
I expect a hot seat here. So the question was, in his environment, he has a mix, and generally what the gist of the question was, he has a mix of SAS and SATA in the environment, and NetApp support's telling you that could be the source of some of his problems. And yes, that can be the case. Now, in normal operation, when both disks are underutilized, we can flush out the write cache normally to both sets of types of disk and no problems occur. The problem when we mix disk types, and particularly SATA, which has very low I/O characteristics versus what the SAS has, is if you overwork the SATA disk, that latency spikes up, And the backlog caused by the SATA disk being stressed can fill up the write cache. And this, again, I think this works on pretty much any storage platform. The NetApp, I just know the NetApp platform will fill up your write cache and prevent the ability for us to actually accept writes that are going to the SAS. And symptomatic is their SAS disk utilization may seem low, meanwhile your SATA is pegged to the nines. So under normal load or correct load, they don't impact each other. But if you stress out the SATA, you can drastically impact the performance of the SAS. Yeah. All right, a few questions.
The question was with the VMware alignment problem, was it just Server 2003? Primarily it was. I would say like 90 to 95% was Server 2003. There were some Windows XP machines mixed in there and a sprinkling of some of the older Linux that we had a problem with.
Definitely older distributions of Linux will do it as well. Yeah. Question?
The purposefully misaligned VMFS
Yep.
file systems, would that increase the I/O whenever you're writing to the VMFS?
So the question was with the optimized data store, you got to use the right marketing term, the optimized data store, does that cause misaligned I/O? It can in the case of something if you're writing at the VMFS layer. Now that doesn't happen very often, but for example, the storage vMotion, when you do something like a storage vMotion and you're writing at the VMFS layer, because the VMFS itself is misaligned, yes, that will cause misalignment. So you have to kind of toe into that environment slowly to get into there. But once the VM is in there, all of the I/O comes from the guest OS, and then that's correctly aligned. The major reason we don't recommend these to be permanent type solutions is you now have data stores that only those misaligned VMs can live in those particular data stores. And so you've kind of increased some of your environment complexity. You can't place properly aligned VMs in there, they'll be misaligned. So you have to create a data store that only VMs that are misaligned by that amount can live in that particular data store. Storage DRS would not be a good fit. I should highlight as well, we can now, since we've done this, we were previewing in the booth as well, we can now do this with NFS data stores as well as LUNs. So we did it initially with Scott with actually LUNs from the command line. We since have a GUI, and we now can do it with NFS data stores as well.
Buddy up here had a question? Oh, well, there you go. Okay. Great minds think alike.
2 for 1.
Yeah, so this was we were running vSphere 4, so VMFS 3 if the code. The block size?
So the question was, would VMFS 5 with atomic the LUN locking or atomic set and correct it? No, they are two different issues. So atomic test and set allows you to have much larger VMFS data stores. You have many more VMs in there without the VMs impacting each other, but does not affect the actual alignment of the individual VMs inside the data store. You still would have that misalignment. If your performance, the question was, would it improve performance because you're no longer locking the entire data store? If your performance problem was the fact that you were getting LUN locking, it would. In Scott's case, they weren't moving things around. They weren't using VMware snapshots. They were strictly using NetApp, so they were not having any LUN locking issues. So it wouldn't have resolved their case. Good. The question was, is there CPU overhead on the storage system with atomic test and set? Not noticeably. I see where you're going. The question was, would atomic test and set, the VAI, increase your CPU load on your storage controller? I can see your point. It certainly could. VAI in Central, in essence, offloads duties to the storage array. So the storage is doing the work instead of the ESX layer. So it could increase your CPU load because we're doing more of the work. But atomic test and set is such a small call that it's not noticeable on the storage controller. We've been neglecting this side of the room.
Yeah, sorry.
So we've been told that from some people that running your NetApp is basically 90 to 100% CPU usage. That really shouldn't affect storage performance. And we do see that, like when you see a graph and you see flat top on a graph, you usually think that's really bad. 100% CPU on your NetApp. You don't see any other religious issues. That's really okay.
Yeah, so the question was, is NetApp system, my NetApp system is running at 80-90% CPU utilization. Is that bad, or is that normal, something I should be concerned with? And the answer is no. Actually, the way that our engineers look at it is you have the CPUs there. If they're not doing anything, you're kind of wasting them. So we have a large number of processes, and low priority processes that will run if you're not actually burning your CPUs. So the system will generally use CPU when it can get it. If you're not using it for primary process, there's a priority system in there, so it'll kick off background processes running that will get suspended if the user data comes in as a high priority. The problem was in this case, and it's tough to tell from just looking at the CPU graph, but when we did the performance analysis in here, the CPU load was being generated by user-generated, right? Those misaligned VMs are actual user I/O, so they were top priority, and so they were dominating the system performance.
Can you show the last slide again and talk about the balance application?
Yeah, I should mention both the balance and the virtual storage console are in the NetApp booth. If you want to see those demos or see them live, by all means come down to the booth to see it. Do we have, so this is actually, this slide here?
That one?
So investment monitoring tools, does that include balance? How is that sort of cost for balance?
There is a cost for balance. You can license it either per... I knew this was coming, that's why I jumped in. You can license it per storage controller, or you can license it per ESX server. There's no per VM monitoring. We will quite often, this is where I'll dodge it, we will quite often in cases where we have performance issues. Now, as Scott said, they were already down the path of a POC, but we have put it in cases where we have an environment that they're having unknown performance problems. We'll sometimes put a balance in strictly to give us some troubleshooting. It's amazing how often we put it in, and it's a good way of just going, hey, look, it's not us. Because right now, there's a lot of times I'm having a performance problem, it must be storage. And we're able to correlate to say, look, you're having a performance problem, but it's not even getting to us, right? The performance issue is happening higher up the stack because we have that very tight time slice all the way through from the guest OS to the ESX layer down to the NetApp. So you can't...
At Christie, we ultimately didn't choose to go with balance, but it's not because of any indication of the tool set or the price, but rather the investment that we already made with System Center from Microsoft. So,
are you all iSCSI or some NFS? Or?
We're all fiber channel. No iSCSI, no NFS. There's the red shirt that was close to you.
That was my question. Block or cloud,
This guy in the striped shirt? So originally, the easiest way to find NetApp misalignment is the on-command balance spat out a report saying, hey, fool, you got all these things misaligned, right? It doesn't talk like Mr. T, right? But,
that's an expansion pack.
Yeah. But with the plugin, the virtual storage console plugin itself, with I think 4.0 is the current one, 4.1 is coming out relatively soon. I think I'm allowed to say that. It sets up a schedule that scans your data stores, and then it slides them into, hey, this one's misaligned by this much, this one's misaligned by that much, and then you can select all your Windows 2003 are known as misaligned by 7, I think is the label that I put. You can select them, it'll create you a new data store that's appropriately misaligned or functionally aligned, and then it'll migrate the stuff into there.
So,
I beg your pardon?
What tool is that?
So, it's a NetApp virtual storage console. It's a plugin that you can put into your vCenter.
are there any other tools out there on the market that we're running?
Yep. We can help you there. No. Actually, EMC, so we initially, I just finished that one off. We found it with the balance report, was the first one I showed, and this is the virtual storage console was the one that Scott just mentioned. From an EMC standpoint, we had MBR Align, which was our alignment tool. EMC actually built a really, really nice alignment tool called Uber Align, and it's part of their toolkit, and it actually works very well. But VMware Converter is sort of our recommended way to correctly align it, which you can use a VMware Converter to do a V2V, which corrects the alignment, but it does require downtime in the VM to do it. I'm not aware of EMC having something similar to do it with just storage vMotion. They may, but I don't know. VMware Converter would be your best bet.
VMware Converter is pretty good. It's easy, GUI, easy.
One of their experts built a system that doesn't use scripting.
That Uber line, is that the one?
No.
It's different?
Ask EMC, I guess.
Yeah.
Every EMC rapper finds insurers walking around because they know what it is.
Guy in the blue jacket. We didn't have much in the way of link clones in our environment, but I don't know.
Come see me at the booth. I probably best on that one. Yes, there is misalignment inherent in link clones, but it's not due to misalignment of those. It's due to the way the Delta file is handled, and VMware has made great strides in correcting that. So that's something that's going away quite shortly.
The guy with the grayish T-shirt.
Yeah, did you find your latency calendars match vSphere what was being recorded on the array? We run NFS and like vSphere, I'll see massive spikes. You lose out a lot of on the VMFS counters since you're running NFS, but the array will sometimes say it's only like a 5 millisecond latency, but in vCenter I'm seeing thousands or something weird.
Do you guys still need me to repeat the questions? Are you guys able to hear that? No. So his question was the latency calendars in vCenter matching what we're seeing on the storage? And in this case, in most cases I have, the answer is no, but it's not really inherent that anybody's lying, but it's how you calculate that latency, right? Is this a read latency, a write latency? Is it averaged? If it's averaged over what time? Is it a sample set? There's so many ways of calculating what that latency actually is. And so what happens with Christie when we got into this case is we gather what's called a perf stat. So if you're, I think most storage vendors have something similar, but this gave us a second-by-second detail of exactly what the storage controller was doing. And we're able to see what was our read latency versus our write latency. And our read latency actually wasn't bad. Our write latency was really hurting because of the misalignment. Basically, the NVRAM or the write cache was just absolutely slammed due to misalignment. Once we cleared that up, then we're able to see overall, that's when those other spikes became clear, once we kind of took away some of the noise and we could see where else we could troubleshoot. So balance is our on-command balance is very good because it calculates the latency top to bottom at the same time slice. The other thing is if your clocks aren't perfectly synced to the millisecond or microsecond, you're going to have shifts that are just enough to cause your numbers to be a little bit funny.
I'm not sure when they're going to kick us out of here, so if you guys have more questions, how about you just come up to the front if you want to hear, unless you really, really like listening to our questions in a big, huge open hall, but just come up to the front. We'll talk to you one-on-one.
We can maybe divide and conquer that way too.
Yeah.
Thanks very much.